Hello, everybody. This is going to be a small walkthrough or mini tutorial, mini beginner's tutorial for Pandas. So Pandas is a data analysis package which we use machine learning for our machine learning and deep learning. Right now, I'm using a Jupyter Notebook where I have installed Pandas. If you haven't, you can do that by pip install Pandas. That should take care of it. You can use Google Colab for this entire tutorial. You don't need to install. You can directly import in Google Colab. So let's begin by importing Pandas. So you import Pandas as PD. This is a common practice. Everybody uses PD. Okay, now what we're gonna create something called data frame. So data frame is how you're gonna see, how you're gonna read your data. So data frame, let's call it df equals to pd dot, you can create data frame from a bunch of different ways, but we are directly reading a file. So you can read a bunch of different types of file, but we just using read CSV file because these are very common. I have downloaded this file from Kaggle. So this is your cancer diagnosis file. Right now, the file that I'm reading is in the exact same folder as my Python notebook. So I just type in there. So that should take care of it. If you haven't, you can enter the exact path name and it will read it. So the way we visualize our data is by something called dataframe.head. So what this will do is it will show you the first 5 rows of your data frame. So by default, so right now you can see it's showing you the first 5 rows. We have plenty of rows, so let's find out how many rows we have. So this is how you can visualize your data. So it will show you all the columns and everything that you have in there. Sometimes the file are not exactly written like this. If they have different separator, then when you're reading it, you have to add that parameters. Either your separator is backslash or colon or something like that if it's not showing properly. So you gotta read it. So this is basically Excel, but Excel for large data. Excel is not good if you have a huge number of data sets. Okay. You can read instead of 5, we have wasting so much space here. You can read only the number of rows you want. So if I say 3, I can read the first 3 rows. If I say 7, I can read first 7 rows. So let's put 3. So now you can see the first 3 rows. Again, you don't have to read the first 3 rows. You can read the last. So you can read data frame.tail. This will show you the last 5 rows. So you can see we are onto the 568, 567. So in this case, this one here is 0, 1, 2. So these are our index. So index begins from 0 and it goes 568. So in total, we have 569 rows. So you can get all those info from a very simple function dataframe.info. So this will give you a overview of everything. So let's start here. So what are the range index? So this tells us we have 569 entries. So that means we have 569 rows. So we have 0, 1, 2, 3 up to 568. And then it will show you all the columns. And now this one is important if you're doing any sorts of machine learning because you don't want any null values. So right now it has 569 rows and for ID 569 non-null values. That means there is something in every rows, which is good. If there is nothing like null values, then that cause problematic. And also it's showing you data types. Let's say int64. Diagnosis is an object type, and then we got float 64 types. Now, if you come over here, look at this one. There is something called unnamed 32, and it has 0 non-null values. That means every value is in null values, and we can verify this. So if you go here all the way to the last one, unnamed 32 right here, it has NaN. So these NaNs are basically null values. So if you're doing any sorts of data analysis, you gotta get rid of this NaN, otherwise your machine learning will go crazy. So I will walk through how would we remove this. For now, let's focus on something else. Okay, so now we have dataframe.info. Another thing you can test is something called dataframe.isNull. So this one will tell is the index 0 column 0 is null, false. So if you notice here, index 0 column 0, the first column is not a null value, so it's a false. But if you go here, index 0 unnamed 32, is it a null value? Yes. So you can see all the way here, this is true, it is a null value. There is something else you can do. This is called data frame is null dot sum, and it will tell you how many null values you have. So this is a check I always do before I do any sorts of machine learning to find out if we have any null values. So you can see on our last column, unnamed 32, it has 569 null values. So we have to do something in theirs. Okay, so now let's see. So data frame is basically a, we'll go over here. So data frame is a, it's basically a two-dimensional data set, right? So you got rows and then you got columns. So each column can be interpreted as a series. So column is basically a one-dimensional data right here. So if you have radius mean. So let's see how can we access the column. So let's say I want to access the diagnosis column here. So there are a couple ways you can access. So you can do data frame dot diagnosis. And when you do that, you'll get the diagnosis column, okay? There is another way you can get access to this is data frame diagnosis, which I commonly use this one, square bracket with inverted comma right there, with the quotation mark I meant. Okay, so this is the same thing. We are accessing the column, so this series, okay? Let's do some statistical operations on columns. So for example, let's say you want to find out how many unique values. So right now I can see we got a bunch of MMM and we got 1B. Is there anything else in this column? How can we find out? Well, we can find out by data frame diagnosis dot unique. So what this unique will shows us how many unique value types we have. I can see we got B and M, so let's find out if we have any. All right, so we don't have anything, so it has only two unique types, M and B. Probably M stands for, not probably, it is. M stands for malignant cancer and B is benign cancers. So we got only two types of data that present in this series. All right. So there's another thing that it's very common. You'll be using this is, so we know that we have only two types we have in there, but how many M and how many B? This is very important check that you have to do when you're doing any machine learning package. So what this will do is it's going to show you value counts. Come on, show up. Okay, so there we go. So it's gonna we're gonna count how many M and how many B we have. So in this case, we have 357B and M is 212. So that means we got 212 M and 356. So this is a common check that you should do before you do any sorts of machine learning, because here's why. So this data is roughly balanced, like it's probably 60-40, so it's kind of balanced. But let's say in a odd scenario, you have 99% are B and only 1% are M. So in this case, if you try to train a model, and your machine learning is gonna basically gonna say everything is B. It doesn't care about M. If you list everything as B, it's gonna get 99% accurate. So make sure your data is balanced. So for this case, our data is roughly balanced. So this is a good way to see if your data sets is balanced or not. So this is few checkups that you should always do. Okay, so now let's look, let's read again data frame dot head. We will read first three again. So in this case, let's try to look at this radius mean. So this has a bunch of numbers, 17.99, 20.57, 19.69. So let's say you want to just find out what is the maximum here. Like in this column, radius, mean radius column, what is the maximum? So let's do some statistical operations on each column. So let's say if you want to find out radius mean, and you want to find out the max. Okay, it turns out the max number for that column is 28.11. Again, it doesn't have to be max. You can do min as well. Again, you don't need to do square bracket. There is other way to access is radius dot data frame dot radius mean. And let's say we want to access minimum value. You want to find out the minimum value. Okay, we got it, 6.981. So in this column right here, in the radius mean column, the highest is 28.11 and the minimum is 6.9811. What if you want to find out the mean? Data frame dot radius mean. So you want to find the average of this thing. Okay, the mean of those thing is 14.127. So for this one, it's 14.127. So this is kind of pretty good if you want to find any statistical data for each column, minimum, maximum. But most important one is this value counts. This will tell you how many different types of data you have and how many unique values you have. So this is, I kind of always check. All right, so that's all about how to access column and how to value counts. Okay, let's try to do some mathematical operations. Let's create a bunch of different columns. So how to create new columns to your data frame. Okay, so the way you can create column is by this data frame square bracket with quotations. Let's call this column name test1. So test1. You can fill this column with one type of value. I can say test1 is 69.420. Okay, so what this will do is, you can see for yourself. So you can see at the very end, we created a new column, test1. And this test1 column is filled with only one type of value, 69.420. So that's what we did. We can create another column. It doesn't have to be a value. You can say data frame test2. We can create a column and we can pass a string to it. So I can say whiskey. Hopefully my spelling of whiskey is correct. Now let's look at here, data frame dot head 3. You must be wondering why I use 3. 3 is, I always use 3. That way you're not going to waste too much space on the desktop. All right, so right now we have another column where every row is filled with whiskey. There is only one type of values, okay? What if we want to create a column, let's say data frame dot sum test. Okay, let's say, let's call it test 3. You can call whatever you want. Let's say we create a column by taking the summation of this radius column and this texture column. So we want to create a new column, just like in Excel sheet, you want to add 2 columns. So let's say you want to add 17 plus 10, and then you want to create a new column at the end. So it's kind of simple. What you have to do is you take radius mean column plus data frame texture mean column. And that's it. So data frame dot head right there. So we created all the columns right here. So we have a new column that is going to be a sum of 17.99, which is radius column, and texture mean column, 17.99 plus 10.38. So it should be about 28.37. There we go. All right, so that's how you can create column and keep adding to your existing data frame. So what if you want to drop the column? All right, so let's start with, remember we said unnamed 32 has a bunch of null values. So how can you drop null values? It's a pretty simple functions. So data frame drop NA. So what this will do is, this is critical, it's gonna drop every single like every single rows or columns any way you want, everything that has NA, the null value. So let me give you a thing. So let's create a new data frame 1 equals to data frame drop NA. So let's see what happens. Okay, so what I created was, I created a new data frame 1 by dropping anything that has NA. So let's see, how does the new data frame looks like? Okay, so you noticed now that new data frame does not have anything, 0 rows. It's basically empty, because what it did was, it took every rows. So when you do this drop NA, it has a by default label that it's gonna drop every rows that has null value. So which means our unnamed 32, every row has null value. So it kind of basically dropped everything, but you don't want to do that, right? So all we want to do is we want to drop only the columns that has unnamed 32. So you just want to drop this column. So you can do that by a few things. You can add something called axis. So by default, the axis was 0. So it was dropping all the rows, but let's change it to axis 1. And you'll see now we have everything, but we don't have any more that unnamed 32. Okay, so we don't have any more unnamed 32. And if you go back, data frame, our original data frame .head, it still has the null values. One thing you can do is when you are doing this drop NA, something called in place. Let me show you. Data frame dot drop NA, and I want to pass axis equals to 1. That means I'm telling drop every column that has NA values, and what you want to do is in place equals to true. So what this will do is, you don't need to create a new data frame like we did here. It will simply drop all the null values and replace the existing data frame. That in place equals to true, it's going to replace the existing data frame. Now if you go back here, our data frame will be a lot cleaner. So you can see here, this has 35 columns now. So the unnamed 32, which was before, it's not anymore, right? So it's gone. Okay, so how would you drop columns? Okay, so let's try to drop our test 1 columns. Okay, so let's see. The way you can drop the columns is data frame dot drop and columns equals to test 1. So we are dropping our test 1 column. Okay, so if I do this, if you notice, I did not pass in place equals to true. So if I do it, so it created a new column, but if I go back to my original column, data frame.head, you'll find out it still has the test 1. So if you want to drop a column and replace the existing data frame, what you have to do is you have to pass in place equals to true. So now you can see if I go back and check my data frame.head again, the test 1 column is gone. Okay, but this is a bad practice. You should not use in place equals to true. Instead, you should create a new data frame with dropped column. Okay, so what if I want to drop test2 and test3 all at once? Again, it's very simple. So let's create a data frame 2. This is a good practice. Data frame dot drop. So now you're gonna say columns. You're gonna pass the columns name as a list. So the first one is test2, and the next column name is test3. Those are the two columns we want to drop. And let's look at the data frame 2 dot head. Okay, so you can see in our new data frame, it has only 32 columns because we dropped test2 and test3, but we did not mess up with our original data frame. Like our original data frame still has test2 and test3. So this is kind of nice as you go along. Like if you're messing with your data set, it's ideal. Like it's a good practice. You should not mess around with your original data unless you intend to. So just be mindful about it, how you're approaching. Okay. Again, you can, instead of dropping columns, you can drop rows. So let's try to do. So let's say we want to create a new data frame 4, and you want to drop data frame dot drop. Now you can put labels. Now labels, you can drop. Let's say I want to drop the first row, index 0. So labels equals to 0. And you can see data frame 4 dot head. You can see the 0 is gone. Now our data frame starts from 1. You can do reset index. You can pass through reset index that will reset, but let's keep it this way. That way we can see what exactly is happening. Okay, what if you want to drop multiple of them? Again, you can do the same thing. You can pass, instead of 0, let's do a bunch of index right there. Labels equal to 0, 1, 2, 3, and see, I dropped 0, 1, 2, and then data frame stats are 3. Again, you don't have to do 0, 1, 2. You can put any index you want. However, let's do a little bit better way. So let's create a new data frame 5. And this time drop labels equals to data frame dot index. Okay, so what if I want to drop everything from 0 to 100? Okay, everything from 0 to 100. I want to create a new data frame 5, where the index will begin from 101. So the way you can do this is you do index number 0 up to 100. Well, 101. So in this case, it will drop everything from 0 up to 1 before, which is 100. And it will create a new data frame where the index will begin from 101. And you can check by yourself, df5 dot head. And you see the index begins from 101. Okay, so let's do another one. What if you want to drop, let's create a new data frame 6. What if you want to drop, let's think about the data. What if you want to drop all the rows that comes after 100? Like you want to drop everything 101, 102 till the end. Well, you can do that by something the same way. Labels equals to data frame dot index. Okay, so you want to drop everything after 101. So the way you can do this is 101 slash 101 colon. So this way it's going to count 101 and anything after that. So you can check yourself. Dot head. Okay, so right now you see data frame dot head. So what this one did was it created a new data frame 6 where it dropped everything after everything, everything after 100, including 101. But how can we see our last 5 data? We can see our last 5 data by instead of using head, we can use tail. So you can see it has the last 5 data of our data frame 6 is 96, 97, 98, 99, and 100. So it has dropped everything after 100, including 101. So it's kind of the indexing method for Python and other programming. So when you have on the left side of the column, this number always counts. But on the right side of the column, it never drops the 101. So that's why the number begins with 101. But here, the number includes 101. And let's create another one, data frame 7. So let's see. Let's do an exercise. See if you can do this. Drop every rows from index 0 to 95. Okay, so how can you drop this one? So let's say you can pause the video here and write the code. Let's create data frame 7 equals to data frame dot drop labels equals to data frame dot index. And then we want to drop everything from 0 to 95. So the left side of the column counts, but the right side does not count. So you have to add one extra. So that's 96. So this means this will drop all the rows from 0 to 95, not including 96. And we can check data frame 7 dot head and see our index started from 96. Okay. So this is all the tutorial. So it is all the walkthroughs. I'll create a more advanced tutorial for this one, and please stay tuned. This file, the Pandas tutorial for beginners, this file will be on our GitHub page. So you can go there and download it yourself and mess around with it. And also I will have the cancer diagnosis file as well there. You can download this on Kaggle as well. All right, stay tuned.